Hello everybody. So I welcome you back in this course Introduction to Sequence Stratigraphy. My name is Biplab Bhattacharya and today we are going to discuss on the concept of scale in sequence stratigraphy. So in sequence stratigraphy, the concept of the sequence, system strats and the stratigraphic surfaces, they are independent of scale. And when I am saying the scale, that means how much time is involved for their formation or for their deposition. When we are talking about the scale, we are considering not about the amount of thickness or the amount of lateral extent of those deposits. So when we try to define a sequence or we try to define system strats or stratigraphic surfaces in the sequence stratigraphic framework, these concepts are independent of any scale in terms of time, thickness or its lateral extent. So that means that the same terminology like a sequence can be used or can be applied for different scales, different orders that are developed through different time and space. So we can use the term sequence for a very small unit of sedimentary succession, as well as we can define a sequence for a very large unit. So this particular concept, how we can apply that and what is the concept behind that, that we are going to discuss in this particular class. So this particular approach applies to sedimentary features which are formed within a very short time span, say for example during an experimental flume where it takes place within few hours and we get certain beds formed, as well as it can be applied to very large scale. For example, when it is in the scale of say few million years or maybe hundred of millions of years, where the succession is forming across the entire basin and there it is forming a very thick succession maybe in terms of few kilometers. So in either of these cases, we can apply the concept of sequence or system strat or the sequence boundary or the system strat boundary, that is the bounding surfaces, in equal terms, because the basic definition, the basic concept of defining a sequence, of defining a system strat that we have already discussed in our earlier class, that remains same irrespective of the time or the thickness of the succession. So this is a very important concept in sequence stratigraphy, because based on this we classify the sequence stratigraphic study into high resolution versus low resolution studies. So the distinction between larger and the smaller scale sequences, as I was telling you about the high resolution and low resolution sequences. So commonly the larger scale or the smaller scale sequences, or the larger scale and smaller scale system strats, or the stratigraphic surfaces. So these are commonly addressed through a hierarchy based on the use of modifiers. So when we are using say larger scale, very widely spread, very thick, deposited through millions of years, maybe we can use first order for them. When you are coming down to little bit smaller in terms of their areal extent, their thickness, their time, maybe we can use them second order. Accordingly, further smaller units, maybe third order, and in that way it can go down. So normally when we are defining a first order or second order, there we can define a sequence, there we can define system strats within those sequences, and accordingly we can define the boundaries of first order, boundaries of second order. So for each level of this occurrence of a particular sequence package, we can have one sequence or multiple sequences, and within each sequence, say for example first order sequence, we can have multiple first order system strats, and in that way it can go down to the second order. So when we are defining a second order sequence, there we are considering that package formed during say 10 million year time scale or maybe 1 kilometer thick succession, and within that package when we are defining a sequence, it will cover or satisfy the basic definition of sequence that we have already discussed. That what is the basic definition of sequence, what are the parameters to be fulfilled for one particular package of succession to be called as a sequence. As we know, a sequence is always composed of at least two or more system strats. So within that particular sequence, we can define multiple system strat, which are the subunits within that particular sediment package. So, they are second order system strats, and it goes on like that. So, in order to classify the sedimentary successions, we have to identify different cyclicities or different packages in terms of the amount of time involved in their formation. So, basically the primary unit that we can define, if I start from the very basic part, very fundamental part, there we can define at the very initial part the sedimentary cycles. So, what are these sedimentary cycles or sedimentological cycles? They are nothing but the beds or bed sets, and as we know that the formation of bed and bed sets, that does not take much time. So, the amount of time involved starts from a few days maybe, and from there it can go up to 100 years, maybe 1000 years maximum. So, this is the lowest rank depositional systems. Within any depositional system, we can get this unit as the fundamental unit, the beds and the bed sets, which will form by normal processes, normal sedimentological processes on day-to-day basis, or maybe in terms of months, or maybe in terms of years. So, if you are looking into the tidal flat system, there every day you can get formation of alternate sand and mud layers, which are forming within a day scale. Whereas, if you look into the deep marine part where turbidites are forming, there it may not be a day scale, but it may be in terms of several months or maybe several years, it is going on for long term. When you are looking into the self mud deposition, pelagic mud is depositing. So, it may go on for hundreds of years or maybe even more than hundreds of years, where one single bed of mud is forming over there. So, depending on where it is forming, in which condition it is forming, the amount of time involved is from few days, even sometime it may be few minutes, to hundreds of years or maybe thousands of years of time interval. So, when we are looking into that package, we commonly consider them as the sedimentological cycles, and they are not directly the part of sequence stratigraphic cycles or stratigraphic cycles. So, when we look into the higher order part, higher order means in terms of higher amount of time, in terms of higher amount of thickness of deposition, higher amount of lateral extent of those depositions, we can define the next phase, the higher cycles, which we call as the stratigraphic cycles. So, these stratigraphic cycles are the base for defining the sequences and the system strats, where we actually are getting the association of these depositional systems, multiple depositional systems within individual system strats. So, beds and bed sets occurring in a cyclic order for a significant amount of time. How much can be the time? At least more than 1000 years, which may span up to 10 to the power 5 years, that means 1 lakh years up to, or it may be even more than 1 lakh year, going into the millions of years. So, when these sedimentological processes or cycles are going on in this scale of time, and they are accumulating a thick succession with significant changes in terms of depositional systems, there we can define the system strats with its component depositional systems, and several system strats, at least 2 or more together, will give rise to sequences. So, when we are applying the sequence stratigraphic knowledge, when we are trying to do a sequence stratigraphic modeling from any succession, there we have to come with this particular distinction. We have to identify sedimentological cycles and the stratigraphic cycles. The definition of sequence will be applicable into the stratigraphic cycles, because on a day scale changeover, on a year scale changeover, we cannot apply the sequence stratigraphic concept. So, it is very important that we have to identify the stratigraphic cycles, which comes in terms of repeated occurrences of the cyclicities. After 1 or 2 classes, we will discuss in detail about the different types of cyclicities and their reasons, their causes. So, there it will be little bit more clear to you. So, I am not going to the detail of that types of cyclicities or the reasons for cyclicities, how they form in this particular class. We are not covering that one in this particular class. We will definitely cover that one in next 1 or 2 classes. So, when we get this kind of cyclic occurrences of the sedimentary successions, we get the stratigraphic cycles, and there, depending on this time range, we can apply the sequence stratigraphic concept. Now, when we are applying this sequence stratigraphic concept, again based on the time interval when you are considering these relatively smaller time intervals. That means the events are little bit more frequent, repetition of the events are little bit more frequent. We call them as high resolution. These are the high resolution cycles, whereas when the amount of time is little bit higher, more than 10 to the power 5 years or even more than that in terms of tens of millions years, in terms of 100 million years, we commonly call them as the low resolution cycles. And accordingly, when we are applying sequence stratigraphy in cycles of this time intervals, commonly we call them as high resolution sequence stratigraphy. That means we are looking into frequent cycles. Within one succession, there we are identifying frequently occurring stratigraphic cycles and we are applying the concept of sequence, system strats and the boundaries. Whereas, in the same succession maybe we are identifying relatively thicker cycles in terms of the events, in terms of the processes, and there we are applying again the definition of sequence, concept of sequence, system strats and the boundaries. So, that will come under low resolution sequence stratigraphy. So, high resolution is nowadays one of the most applied area in most of the industries, particularly the oil industries, where people are working on this high resolution sequence stratigraphy, but definitely the work starts from low resolution. So, whether we are looking into the sedimentological cycles or whether we are looking into the stratigraphic cycles, there our entire observation, entire interpretation depends on one primary factor, and that primary factor is the stratal stacking pattern. So, that means what is the meaning of stratal stacking pattern? How individual stratum or a series of strata are stacked one after another, and due to that stacking pattern, due to that nature of the stacking, is there any changeover? So, many a time we get changeover and that changeover indicates change in the process or change in the condition. So, that changeover when we are looking in terms of beds or bed sets, that simply indicate change in the depositional process in that particular localized area. But when we are looking into a stratigraphic cycle, when it is spreaded all over the basin and there we are getting change in the stratal stacking pattern, that definitely indicates a change in the depositional system. And this change in stratal stacking pattern is the key for identification of system strats, for identification of cyclicities, whether it is a low resolution or high resolution cyclicities or it is a sedimentological cyclicity. So, this particular concept, this low resolution, high resolution stratigraphic cycle versus sedimentological cycles, this is the scale concept. This actually gives us the idea about in which scale we can apply the sequence stratigraphic concept. So, in this context, I should mention over here that the depositional systems and the system strats which commonly we observed in different scales can reflect different dominant trends. For example, in terms of the stratal stacking pattern, for some time we can get long term progradation which overlook the higher frequency changes in the depositional environment that fall below the common resolution, say for example the seismic resolution. Because you know, in sequence stratigraphy, to understand the basin scale changeover, seismic profiles are the best tool, where straightway we get idea, a picture about what is there in terms of different rock components, different stratal organizations, how they are occurring. And so, looking at seismic profiles, we can straightway interpret about the stratal stacking pattern in relatively larger scale, where we can get patterns like progradation, aggradation, retrogradation like this. So, when we look into this kind of pattern and we get a changeover, so definitely that indicates some sort of change in the depositional condition, some sort of change in the depositional system. So, if I am talking about low resolution versus high resolution, it may happen that when I am looking into low resolution cyclicity, in that cyclicity I am getting an overall retrogradational pattern, say maybe for 1 kilometer thick succession, there I am getting this entire 1 kilometer thick succession is giving a retrogradational pattern, a fining upward stratal stacking pattern. But when I am coming down to high resolution, that is I am increasing my observation scale in terms of identifying the high frequency cyclicities. So, I am coming into the high resolution sequence stratigraphy. So, there maybe within that 1 kilometer thick retrogradational succession, we can identify relatively smaller progradational successions which are present in between that overall retrogradational pattern. So, those progradational stratal stacking pattern, that means the coarsening upward stratal stacking pattern present within that overall fining upward pattern indicates there are short term fluctuations, short term changes in the depositional system, short term changeover in the depositional conditions which may not prevail or may prevail across the entire basin. So, we can identify those small scale changes, high resolution changes maybe across the basin, or maybe those are confined in certain portions only. It depends on the depositional condition and distribution of the depositional systems across that entire basin. So, as the subject has evolved, initially it started from second order low resolution sequence stratigraphy. At that time there was no concept of low resolution versus high resolution. So, initially it started with maybe second order cyclicities which are spanning in terms of tens to hundreds of million years, and gradually later on as we got better equipments with us, better technologies with us, and also as the subject gradually evolved, the subject gradually grown up, now we can very easily identify further smaller scale fluctuations, further smaller scale cyclicities which lead us to interpret about the high resolution sequence stratigraphy. So, in sequence stratigraphy, identification of the bounding surfaces which are most commonly the discontinuity surfaces, the unconformities, their identification is very important. And when we are looking into these resolutions in terms of low resolution versus high resolution sequence stratigraphy, so there identifying the unconformities or the bounding surfaces become very important. When I am saying a second order sequence within a low resolution sequence stratigraphy, so I have to find out unconformity in second order which will be covering up that entire package, maybe 1 kilometer thick succession, that entire package at the top and the bottom we should have two distinct discontinuity surfaces which we can identify across the entire basin. But as we are now narrowing down and we are going into high resolution sequence stratigraphy, there it may not happen that we are getting that unconformity or similar kind of unconformities available for all such cyclicities of high resolution. We may have to identify the sequence elements like systems tracts or the sequence itself even when there is no unconformity, or even if the unconformity is present, but it is not spreaded across the entire basin. So, there comes the concept of correlative conformity. So, that we will discuss later on. So, many times one unconformity may continue into a conformable surface in another part of the basin. This happens very frequently when we are looking into high resolution sequence stratigraphy. So, we can take one example over here. Say you have one succession which may be say 1 kilometer thick. So, we are defining this as a sequence as it is bounded by these two unconformity surfaces, which is a major unconformity surface. So, maybe this sequence is numbered as 1. This is a very low resolution because this is 1 kilometer thick succession which have formed maybe say in 10 million year time. So, definitely in terms of time interval, when you are looking into this entire package, it is a low resolution sequence. So, definitely this surface, these two bounding surfaces are, say for example, if I am talking about this is the second order sequence. This is the second order sequence. So, definitely these boundaries are the bounding surface for the second order sequence. Now, we are going into higher resolution. So, we are trying to look into the cyclicities present in between these entire succession. So, maybe this entire succession initially was a fining upward succession. This is the grain size coarser to finer, it is getting finer upward. So, overall retrogradational pattern. But when we are looking in higher resolution within it, maybe within this initially in this part there was a fining upward followed by one boundary, then there is a coarsening upward, again there is a boundary, then there is another finding upward. So, we are getting one surface which is present across the entire basin, which you can trace, but this surface, it is not present over here. So, this particular surface cannot be traced across this second order cycle, but this can be traced when we are looking down into maybe the third order. So, within this third order, which is spanning in terms of say few million years, 2 to 3 or 4 million years. So, there we can identify this surface or this surface which is separating out the stratal stacking pattern in a different way. So, now we have 3 different packages which we will call as the high resolution packages or maybe the third order packages, and maybe we can define them as the third order sequences. Now, these units may be the system strats for the second order, but when we are looking into third order, they become the sequence, and when they are becoming sequence, definitely within them we can identify system strats. So, maybe we can again look into only this part. So, we can name it as say 1A, this particular finding up succession. So, within this 1A package which has formed maybe within 4 million year time, maybe within this we can again find out say initially a finding up followed by another questioning up followed by another finding up. So, definitely we can get a boundary over here like this. This boundary is separating this finding up and questioning up. This boundary is separating this questioning up and finding up succession or cycles, but we cannot trace it over here or over here. They are not traceable in that scale. So, again we are getting an unconformity or a bounding surface over here which is not laterally present or persisting across the other part of the basin, or they are not observable when we are looking this in a larger scale. When we are reducing our scale, when we are narrowing down our scale, and when we are zooming in, then only these unconformity surfaces are observable, they are recorded. So, maybe this one is say for example 1AA, this is the term. So, definitely these are the system strats within this 1A, if that is a sequence. So, these are the system strats of third order, and these are the boundaries for third order sequence. So, in between that we are getting again boundaries separating these system strats. So, these are the third order system strat boundaries. Similarly, if I look into this 1AA now in further detail, which may have formed maybe within say 1 million year time. So, again maybe we can find out one finding up, another questioning up, another finding up succession, and they are again getting separated out from each other by distinct boundaries. But here individual cycles may have formed within say 1 lakh year or maybe 5 lakh year, maybe 10 lakh years, and accordingly you are getting a succession. So, maybe I can term this one as 1AAA, and in that way it will go on. So, when I am getting this particular surface over here, they are again discontinuity surfaces, but these discontinuity surfaces are not laterally traceable when I am looking in this particular scale. They are confined only over here in this part, they are only confined in this portion. I cannot trace them over here or over here. At the same time, when I am increasing my scale of observation, when I am coming to second order or third order, there I cannot observe them because their resolutions, their significance in terms of their occurrences are little bit meager, less with respect to this dominant cyclicity. So, it depends on in which scale we want to interpret. If we are satisfied with this first cycle, we can just define the major bounding surfaces, and from there on we can straightway interpret this is the major changeover, this is the sequence. But if you require to interpret in much higher resolution, if you want to trace out one particular sand body, maybe a delta mouth sand bar, how it is distributed, because that may be the potential hydrocarbon reservoir. So, you want to know what is the exact distribution pattern of that particular delta mouth sand bar and what are the units overlying and underlying that. So, there we may have to come over in this kind of scale, which is definitely the high resolution sequence stratigraphy, where we are applying again the definition of sequence, system strats, sequence boundaries in the same way as we are defining over here. Only their lateral extent, their distributions, the amount of time is decreasing. So, when we are dealing with this high resolution sequence stratigraphy and also we trying to define different sequence stratigraphic elements, there we have to select the sequence boundary based on the change in the startle stacking pattern, because in many cases the unconformities may not form or may not demarcate the sequence boundaries or the system state boundaries. So, to define a sequence or a system stack in high resolution may not always require the presence of an unconformity across the basin. Only a small presence, a small lateral extent of that unconformity, or maybe its coeval contemporary conformable surface which you can correlate with that unconformity, can act as the boundary for defining a sequence or a system stack. So, initially when this concept of scale was involved and gradually these higher resolution cyclicities were identified, then there was a requirement that we should classify these units into different orders or different terminologies. So, initially people used to define them in terms of parasequence, which is the basic unit. Several parasequences produces a sequence, several sequences produces a sequence set, and accordingly we can get several sequence set producing a composite sequence, and then composite sequence producing a composite sequence set, which may look like this. So, the basic unit is the parasequence, several parasequences constitute a sequence, several sequences produces a sequence set, several sequence set produces a composite sequence, and goes on like that. But the problem over here is there are certain complexities or rather confusions while using these terminologies. Why? Because this leads to certain nomenclatural inconsistency, because when I am using the word sequence and then I am using the word system stack, or I am trying to identify the system stack, so those system stacks can be the parasequence for that particular sequence as per that particular classification, and when I am going to the next order, further lower order sequence, there this first sequence will be acting as the parasequence for the next order. So, in that way, when we are defining the sequences, system stacks and the contemporary parasequence or sequence set, etc., which are identified within low resolution data set, they become sequence set for high resolution data sets. And when you have several such orders of cyclicities present, then it becomes very much confusing and very much overlapping. So, we face a nomenclatural inconsistency with this kind of terminology. So, this has been changed nowadays, and instead of using these terminologies like sequence set, composite sequence like this, straightway we use the order. So, it is first order, second order, third order, fourth order, and it goes on like that. So, this leads us to a new approach which actually overcomes this nomenclatural inconsistency, and we call it as the nested architecture. So, when we use nested architecture, that actually helps us to distinguish the individual packages of sediments, individual cyclicities within sediments in different orders. So, we can take one example over here. We are starting with some beds. So, the time involved over here is maybe 10 to the power 0 year, for example. So, several beds and bed sets, they will get accumulated and they will show certain startle stacking pattern. So, through that stacking process, what will be produced will lead to, this will lead to some system stack. So, this system stack is produced in terms of 10 to the power 0 year or maybe 10 to the power 1 year, maybe maximum 10 to the power 2 years. So, 100 years term. So, definitely this I can call, for example, maybe the fifth order. I am starting with just a number, fifth order cycle or the fifth order sequence. So, in this fifth order, I am defining a system stack or multiple system stacks. So, when these system stacks will accumulate one after another and they will be bounded by a discontinuous surface or two discontinuous surfaces below and above, what we get is a sequence. So, this sequence is the fifth order sequence. Again, this sequence will have several such sequences accumulating one after another. So, again we can get a stacking of these sequences together, and together through the stacking of these sequences, what we get is again a system stack. Now, definitely this system stack is getting accumulated through several sequences which have formed in terms of 10 to the power 2 years. So, definitely this system stack is ranging in terms of 10 to the power 3 or maybe 10 to the power 4 years. So, when we are talking about this, definitely this system stack forms the fourth order. This is definitely lower order with respect to this fifth order, and several system stack in this scale together will form sequence. So, what is this sequence? This is the sequence of fourth order. In the same way, again there will be stacking of similar sequences. So, these sequences may be 4, 3, 2 sequences together will stack together and they will again form a system stack. Now, this sequence was ranging in terms of 10 to the power 4 year. Now, when you have several such sequences stacked together, the system stack now that has formed will be higher in terms of time frame, and several such system stacked together will form a sequence. So, definitely in this sequence what we are getting, the amount of time involved may be 10 to the power 6 year or maybe 10 to the power 5 years. So, this 10 to the power 5 year term, so we can call it as the third order sequence. So, this third order sequence is consisting of third order system stack and they have a distinct boundary. In the same way, again several third order sequence may stack up and form a system stack, and that system stack will be the second order. So, because that will be in terms of 10 to the power 6 years, and several system stacks of the second order will produce a sequence of second order, and it goes on like this. So, when we try to build up the sequence model in this way, it is called as the nested architecture of sequence stratigraphic framework. So, here each and every component is interlinked. Maybe we are starting from the sequence of second order, and from there gradually we can come down to bed scale, or it can go on the reverse way. We can start from the bed scale and there we can look into the stacking pattern, we can look into the bounding surfaces, and gradually we can build up different sequences of different orders one after another, and we can come up to the low resolution component. So, this entire nested architecture, it depends on our scale of observation and our need of interpretation, in which scale we require to interpret. This is very important concept. Later on also very often we will be applying or recalling this particular concept. So, these are some of the references, some of the books that you can follow. So, thank you everybody.